Hey there, math whizzes. Welcome back to MaestroMathVortexpg. Today, we're diving into the world of adding and subtracting decimals, but with a high-tech twist. Meet Digit, the holographic robot of the future. Digit's here to help us break down decimals, line them up, and solve them with ease. So, grab your notepad, power up your brain, and let's master decimals future style. Let's go! Initializing math mode. Let's crunch some numbers. Max and Zoe loved exploring the futuristic math superstore. Today, they were on a mission to solve the mystery of the missing decimal. At the center of the store, a holographic robot named Digit greeted them. Welcome, young mathematicians. A glitch has scrambled the store's decimal inventory. Some numbers are missing, and we need your help to restore balance. Max looked at the glowing equations floating in the air. We can do it. What do we need to do? Digit projected a shopping list. We have positive 3.5 tenths calculators, or 3.5. We have negative 2.8 tenths, or we can say negative 2 and 8 tenths. For the first one, it's 3 and 5 tenths. So we have negative 2.8 geometry kits. Next is we have positive 1 and 2 tenths graphing books, or 1.2. And then lastly, we have negative 4 and 6 tenths number cubes, or negative 4.6 number cubes. The total needs to be calculated correctly so that the checkout system can work again. So, Max and Zoe had to bring out their uh, smart math pad. Wow, that's cool. That's amazing. Yes, that's cool. So they had to bring out their what do you call this? Their math smart pad in order to help Digit solve the equation. All right. And so Zoe pulled out her smart math pad and started adding the positive numbers first. Okay. So let's have our pen. Okay. So we'll have the positive numbers first. So we have 3.5, or 3 and 5 tenths, plus 1 and 2 tenths, okay, or 1.2. So what will we get if we add them? So we need to add, I repeat, the positive number first. That's what Zoe and Max did. So 3.5 plus 1.2. All right. So 5 plus 2 would give us 7, and then the decimal point, and then 3 plus 1 is 4. So that would be 4.7, or the proper way to read it is 4 and 7 tenths. All right, so we're done adding the positive number first. Now we add the negatives. So we have negative 2.8 or negative 2 and 8 tenths, okay, minus 4 and 6 tenths, okay, or minus 4.6. All right. So in this case, what do we need to do? So almost there, according to Zoe. All right. So what we need to do here is just add them. And remember our lesson regarding adding integers with the same negative sign, right? So we're just gonna add them and retain the negative sign. So that would be negative 2.8 plus negative 4.6. Let's add. So that would be what? Okay, that would be 8 plus 6 would be actually 14. Carry 1. So that would be 2 plus 4 is 6 plus 1. Okay. Uh, 4 plus 2 or 2 plus 4 plus 1 would give us what? Would give us 7.4. Now, since they're both negative, we're adding two negatives. We just retain the negative sign. So we have negative 7.4. All right. Now, we're not yet done. Okay. We're not yet done. Okay. All right. So I think digit would say something. Okay. Hold on. Oh, sorry. Let's go back. All right. Let's hear what digit would want to say. Okay. Let's just turn off our pen and let's listen to digit. The total needs to be calculated correctly so that the checkout system can work again. Okay, got it, digit. All right. So what we're going to do now is, of course, we're actually almost there, according to Zoe. We just need to add 4.7 and negative 7.4 together. So let's do it. Okay, let's erase this one. Let's erase all. All right. All right. Okay. So we now have, so what we're going to do now is to, um, yes, add 4.7, okay, plus negative 7.4. All right. All right. So what will happen here is, okay, we will actually what do you call this, we will actually subtract here because when we have positive and negative, so always put uh, what do you call this, negative 7.4 first because that's the greater magnitude of number, okay, and then we'll have 4.7. All right, okay, let's do it. Okay, so of course we cannot subtract 7 from 4. We will borrow 1. So this will become 6. So this will be 14. Okay, that would be 7. Bring down the decimal point. And what is 6? 6, of course, 6, negative 6, I mean to say, plus 4, it will give us negative 2. Okay, so our answer would actually be negative 2 and 7 tenths, okay, or negative 2.7. Okay, why is it negative? Because we can obviously see that the number or the decimal which has the greater absolute value on this one is actually negative 7.4. So that's why our sign here for our difference would be negative 2.7 or negative 2 and 7 tenths. Right? Okay, that's our answer. Digit's eyes lit up. His eyes lit up. Excellent work. You've cracked the decimal code. The store's shelves began to glow as the missing items reappeared in their correct places. Max and Zoe high fived as Digit rewarded them with a special holographic math badge. Math is awesome. It's awesome. Zoe cheered. And so is adding and subtracting decimals. Max laughed. As they left the store, they couldn't wait to return for another math adventure. All right, I hope you liked the story about Digit, about Max and Zoe, and their adventure about adding and subtracting positive and negative decimals. And since I mentioned that, so our lesson for today is about addition and subtraction of positive and negative decimals. Okay, for our vocabulary for this episode, we have, of course, number one, we have decimals or decimal. So when we say decimal, we mean that it's actually a number that includes a decimal point. And then number two, we have positive decimal. So when we say positive decimal, a decimal number greater than zero. For example, we have here 3.5. That's the usual, how we usually read it, but there's a proper way to read this one, basing on their, of course, place value or the place value of the digits. So you actually read this one as 3 and 5 tenths. That's why, if you notice, I was reading them the right way a while ago. And then we have, of course, negative decimal. So a decimal number less than zero, of course, example would be negative 2 and 3 tenths. And then we should not forget, of course, that we will be encountering the word addition and subtraction. So when we say addition, it means combining or putting together, right? And then for number five, we have the operation of finding the difference, taking away, right? Okay, and then the sum. This is actually the result when you have added two or more numbers. And then the difference is the result when we are subtracting one number from another or taking away another number from another. Yes, okay? And of course, I know you're familiar with this already. We have the number line. This is actually a visual tool that can help us to understand better whenever we're adding and subtracting decimal because it represents numbers in a straight, okay, in a straight line showing the position of positive and negative decimals. Okay, so those are our vocabulary for this day. Now, we must understand, of course, the parts of a decimal, of course, So, for example, we are able to see this one. Actually, this is read as 49, and um, that's actually read as 49. Of course, the decimal point is there. It's like the separator. It's actually read as 49, and decimal can also be called and 1500s. Okay. But before we go there to the place value, we should know first the parts of our, of course, the decimal, which is a decimal, which is the whole number, and which is the fractional part. Now, the whole number, okay, we just want to acknowledge that we have taken this photo to splashlearn.com. Yes, thank you for allowing us to borrow this picture from you for the sake of learning and educational purposes. So the whole number is written to the left of the decimal point. So this is just a review of what we have already learned in the sixth grade or fifth grade or elementary. Okay, I would like to repeat and give emphasis to that. The whole number is written to the left of the decimal point. So whenever um, we would look and see a number which is in the left of our decimal point, that is our whole number. Now, of course, we have the decimal, which separates the whole number, and of course the fractional part. Now, the fractional part is written to the right of your decimal point. So I just discussed that with us so that we know it's essentially important for us to know which is the whole part, okay, and which is the fractional part. And of course, our decimal is the one separating the whole number and the fractional part. All right, next. So, as I said, I already mentioned that the whole number is on the left side. Yes, the fractional part is on the right side. The decimal point makes it simple to read a decimal number. So, when we use n, in place, of course, we are actually referring to our decimal point. Okay, so to sum it up, the whole number part is read as it is or as is, and the decimal point is read as end. Yes, so when you say end, that means that's the decimal point. And then the fractional part is read as per its place value. So we will get into that, I think, right after the next slide. Okay. Yes. So, as I was saying, it is important too for us to understand our place value chart. Okay. Okay. What is the importance of that? It is very essentially important for us to know um, the place value chart, for decimals. It's crucial. Why? Particularly in adding and subtracting signed decimals. Because why? It actually ensures the digits are aligned correctly. Okay. I would say aligned correctly. Okay. That's why it's important for us to know this. What should be aligned correctly according to their place value? Okay, place value. So the digits should be aligned correctly. Okay, according to their place value. Okay, so it actually allows us to properly add or subtract the corresponding parts of each number. Okay, especially when we're actually dealing with different decimal places and signs. Okay, so of course we have the decimal part here. Okay, on the right side, or we have of course, the fractional part. We have tens, hundreds, thousands. That's why um, if we're gonna read this one, uh, so we can read it as 49 and 15. 15 what? So of course, 15's position is actually in hundreds. So we would read this as 49 and 15 hundreds. Okay? So that's why it's important for us to be able to really understand and be able to remember our decimal place value chart. Okay? So that's 49. Yes. 49. Okay. So I'm just properly placing the digits to their proper place value. Okay. So 4 is in tens, 9 is in ones. Then we have the decimal part. Okay, and then after that, the fractional part. 1 is in tens, and 15 is in hundreds. So as I said, it is read as 49 and 15 hundreds. All right. Now, okay, so we have here our number line. Okay, number line is actually important too because this will actually help us understand more our, what do you call this? Uh, whenever we are adding, whenever we are adding positive and negative decimals, right? Okay, so here we have example number one, which is adding positive and negative, what do you call this? Negative decimals. So we have here 4.2. Sometimes I accept 4.2, but supposed to be it's 4 and uh 4 and what? Okay. If we go back to our place value chart, okay, so it's actually 4 4 and yes, 4 and 2/10. Yes, because uh, the digit 2 is actually in the tens place value. Yes. So it's like, yes, okay. 4.2 or 4 and 2/10 plus negative 2 and 5/10. Yes, okay. All right. So what should we do here first? Okay. So the first thing that we need to do is, of course, to locate 4.2 or 4 and 2/10 in our number line. So basically it's positive, right? It's positive. So all positive numbers, as we all know, right after 0, going to the right, yes, going to the right, or on the right side, of course. So whenever we're locating decimals, of course, we need to actually see where 4.2 is actually closer. When I say closer, so we can look at the whole number here, so which is 4. So basically, it's closer to 4.2 is closer to 4. So it's right here. Yes. So here we can actually use the whole number part of our decimal in order for us to locate 4.2. So as we all know, 4.2 is actually closer to 4. So that's where it is, okay? 4.2. Now, how will we now locate, of course, negative 2 and 5/10? Okay, so this is very important because, it helps us to be able to really see. The number line helps us to actually visualize how we locate, how we plot, how we use it to get the sum or difference of, you know, of adding and subtracting positive and negative decimal. Now, here the strategy is very simple. So, since we have, okay, negative, or we are actually adding negative 2.5 or negative 2 and 5/10, we can actually separate them. Okay, so what do I mean when I say separate them? So I would say that I would um, separate, okay, separate negative 2.0. Okay, and then we'll have 0.5. Okay, so basically kind of separate them because that's actually one of the best way for us to be able to really plot our numbers or decimals. So we have a 4.2, and of course, since we're adding negative 2.5 to 4.2, right? Okay, so what we're going to do first is for us to subtract 2 to 4.2. I repeat, we will subtract 2. That's understood. Negative 2.0. Okay, negative 2.0. We subtract that from 4. So it's going to basically give us, of course, 2.2. Okay. Now we're going to locate where 2.2 is. So by estimation, 2.2 is actually closer to 2. So it's right here. Yes, okay. So from here, we actually move to the left, right? Yes, okay. So 2.2. Yes, okay. Now, is that the final answer? No, it's not. We will continue with our what do you call this? With this time we have to subtract zero point 0.5 to 2.2. Okay, let's do it. So 2.2, okay. Okay, 2.2 minus 0.5. Hold on. 2.2 minus 0.5. All right, so we cannot subtract 5 to 2, so we're going to borrow 1. So this becomes 12. 12 minus 5 would be 7. Okay, and then bring down the decimal point. And then this will become 1. 1 minus 0 is 1. So therefore, our final answer would be 1.7. Okay? So actually 1.7 is also closer to 2. So it's right here. Okay? So you can see that we were able to get our answer by means of the use of number line. Yes, because it's important, you know, to be able to. It's like our conclusion here is that uh, we actually move from 4.2 to 2.2 by subtracting 2, and then further move to 1.7 by subtracting zero point 0.5. Yes. So basically, to sum it up, it means that we do not move directly to 2.2 from 4.2 without considering what operation? Subtraction. Instead, you first subtract and then subtract zero point 0.5 to reach 1.7. Makes sense, right? Yes. Okay. All right. So it makes sense, right? So we separated 2 and zero point 0.5 when we evaluated 4.2 plus negative 2.5. Why did we do that? Because that method of breaking down the operation into smaller, and it's actually manageable, a manageable step. Okay, so that's why we did that. We kind of separate um, 2 and zero point 0.5 because it's easier for us to be able to to be able to solve the problem, to break down. Actually, what we did is break down the operation into smaller and manageable step. Yes. Okay. So yes, the number line can actually help us to see better how to actually plot whenever we're adding positive and negative decimals. So our final answer, of course, is 1.7. Yes. All right. Next, I hope it makes sense to us of that explanation. Next. All right. And of course, why did we move to the left uh, from 4.2? Why did we move to the left? Because we are subtracting negative 2.5 from 4.2. So that's why we're moving in an opposite direction. If it is negative, the movement is always going to the left. And if we're adding, the movement is always going to the right. Yes? All right. Next. All right. How about this? Subtracting positive and negative decimals. So in this case, excuse me. Oh, my bad. Bless my heart. All right. So for example, 2, we now have subtracting positive and negative decimals. So our example here is 3 and 5 tenths minus negative 1 and 2 tenths. Now, in this case, all we need to do is just add the opposite. So we're basically going to rewrite this. Add the opposites. Add the opposites. Okay, so when we say add its opposite, so what will happen here would be 3.5 minus, okay, it won't be minus anymore. It would be addition because add its opposite. So your negative sign would change to positive, and then the sign, of course, of 1 and 2 tenths will become positive 2, 1.2. Okay. All right. So basically, it is now an operation that involves addition instead of uh, subtraction, right? Now, first, we have to locate where 3.5 is. Now, 3.5, by common sense, is actually located between 3 and 4. And since it's positive, so again, it goes to the right, right? Right after 0. So going to the right are all positive numbers. So since it's positive 3.5 or 3 and 5 tenths, we know it by common sense that it is actually between 3 and 4. Now, so what do we do? So we're also going to do what we did to the first example. Of course, but this time, a while ago we were subtracting, but now we're going to add, right? So I'm going to break down, okay, 1.2 into two parts, right? For us to make it smaller and manageable, right? Okay, so we have, how will we break this down? So I'll have 1.0 and zero point 0.2. Yes. Now I'm going to add 3.5 plus 1.0. So that would be 5, okay? And that would be, so we're adding now. 3 plus 1 would be 4.5. Now, so a while ago we were moving to the left. Now we're going to move to the right because they're both positive now. So from 3.5, we're going to jump going to the right to 4.5, which is right here. Yes, that's between 4 and 5. Going to the right, of course. Now, next, we're not yet done. Next is we're going to add the remaining 4.5 plus 0.2. Okay, we're going to add it, okay? All right, so that will now become, okay, okay, so 5 plus 2 is 7, and then 4 plus 0, okay, 4. So that will now become 4.7. Now, actually, 4.7 is pretty much closer to 5, so it's right here. Okay, so the answer now is 4.7. You see? So using the number line can actually help us visualize the problem whenever we are adding, um, adding or subtracting positive and negative decimals, right? Okay, so was it clear to us? Does it make sense to us? Yes, of course. So um, it actually involves estimation. So whenever we are locating decimals on the number line, because first you have to identify the range before you can actually place your decimal on the number line. For example, a student can actually estimate a position by identifying the whole number it falls between. I mentioned that already, just like a while ago. So 3.5, okay? So it's actually at the middle of 3 and 4. Yes, okay? Another example is if you are For example, you're locating 2.7. 2.7. So basically, 2.7 is actually between 2 and 3, right? Yes. Well, let me just write that down. Between 2 and 3. So that's what you call identifying the range. Now, dividing the segment, once the range is identified, that means you can estimate where the decimal falls within that segment. For example, 2.7. So what you're going to do here is you can divide, okay? You can actually divide, or they can divide the interval between 2 and 3 into what? Into 10 equal parts, representing tens, yes. And determine that 2.7 is 7 tenths of the way from 2, uh, 2 to 3, yes. So we actually involve here identifying the range, yes, and then dividing the segments. So I'm just giving, and then approximation. So when you say approximation, it actually helps us, of course, to actually make quick decisions about where our decimals should be placed without needing precise calculation. So this is fostering a better understanding of decimal values and their relationship. Okay, so those are important things that we should remember whenever we are adding and subtracting positive and negative decimals. So at least we're able to see here the use of number line and how it helps us to have a visual representation whenever we're adding and subtracting positive and negative decimals. All right. Okay. So we move on. Okay. This time we are going to, of course, this time we're going to learn adding um, decimals, subtracting decimals, particularly positive and negative, without the use of number line already. Okay, so what we're going to do now is to have our examples. A while ago, those are just introductions, right? Okay, now we have here example A, adding two positive decimals. So we have here 52, 52 and 30 hundreds plus 21 and 82 hundreds. Okay, so how do we add them? Of course, we add them by, of course, align the decimals. Okay, well, let's start with example A. So we have 52, 52.30. That's another way to read it. 52.30 plus, sorry, 21.82. Okay, or 21 and 82 hundreds. All right. So, and then our next step is we start with what? We start with, excuse me again. We start with what? We start with from the rightmost digit. Okay, so this is the rightmost digit. So what do we do? So we have 0 plus 2 will give us 2. All right. And then, okay, so what is this? So, okay, so 3 plus 8 will give us 11. All right, then carry 1 on this side. Okay, carry 1. That's 1. Sorry, it's kind of thick. All right, so we'll clean that one later. Okay, so what is 2 plus 1 will give us 4. Put the decimal point there. And then 5 plus 2 will give us 7. So the final answer would be 74.12, or excuse me, 74 and 74 and what? How do we read that? Okay, 74 and 12. Is it tens or hundreds? It's actually 12, uh, uh, 12 tens. Yes. Oh, sorry. It's 12 hundreds. I'm sorry. So let's go back to that and see. Yes, that is 74. Okay, let's just correct that because we want us here to be accurate and precise. So that would be 74 and 12 hundreds because the place value of 2 is actually, when I say 2, I'm referring to this one. The place value of 2 is in hundreds. Hundreds. Okay, so again, that's 74 and 12 hundreds, not tens. Okay, or 74.12. Okay, so that's how we do it. Okay, easy, right? Next, so that's for example A. How about for example B? Okay, so this actually applies the rule whenever we're adding integers with the same sign. For example, if you're adding negative, sorry about that, negative plus negative, of course, that will always be negative. Okay, excuse me, I'm just gonna sneeze. My bad again. Okay, all right, so my apologies. Having a bad a bad cough maybe, I don't know. Okay, so anyway, going back for example B, we have adding two negative decimals. So in this case, all we have to do is just add them and then retain the negative sign, right? So we have negative 12.05, or negative that's negative 12 and 500s, yes. Okay, and then plus negative 1 and 23 hundreds, or negative 1.23. Okay, let's add. So if I'm going to add them, I'll have, of course, we have 8. Yes. Okay, and then we have 2. Okay, and then bring down the decimal point. So we have 3, and then bring down 1. And then since I said negative plus negative will be equal to negative 2. Okay. All right. So the final answer would be, um, hold on. Okay. The final answer would be negative 13. Yes, negative 13 and 28 hundreds. Yes, and 28 hundreds. Yes. Yes. Or negative 13.28. Yes. Okay. So it's easy to actually add two positive decimals and add two negative decimals. All right. Yeah, it's easy. Okay. So we go to the next one. All right. Now, this time we go to subtracting, okay, or subtraction, okay? Subtracting a positive decimal from a negative decimal, and what do you call this? Subtracting a negative decimal from a positive decimal, which means basically we're just adding its positive counterpart. Now, let's start with the first one. The first one is excuse me. The first one is we have, of course, what do you call this? Example C. Example C states that it's 582 and 72 hundredths minus plus, okay, 805, and okay, that is read as 805 and 200 3 203 203 thousandths. Yes, okay. Now, how are we going to subtract this? Of course, a while ago, I think we encountered this already in our example when we were using the story about digit Max and Zoe, right? So how will we subtract this one? Of course, now we will subtract this. It's kind of easy. It's easy. So first is what we're supposed to do here is to put. Okay, we have to remember that we have to put 805.203 above. I repeat, we have to put first or above uh, 805.203 first. We have to put it above 582.72 because it's actually the number of greater magnitude. Okay, so that's it. Okay, so this will be 805.203. Okay, and then we're going to put below, of course, 5 582.72. Okay, and of course, what operation of course would involve our problem? So basically we have negative and positive, so this is subtraction, of course, right? Okay, so this will basically be negative. Okay, negative. Yes. Okay, and then we can now begin the process of subtraction. All right. Okay, so I don't have a digit over here, so that automatically means it's zero. All right, so let's do it. Okay, are we ready? Okay, yes, we're ready. So, of course, the first one would be what is 3? Okay, 3, 3. Okay, okay, and 0. Okay, that would be 3. All right, so basically, this is plus. Okay, okay, so we're subtracting. And then in this case, we have 0 here. So, okay, we need to borrow 1 from 2. So this will become 1. Okay, I'll borrow 1. So this becomes 10. Okay, so what is 10 minus 2 will give us 8. All right, again, we need to borrow 1 from 5. All right, so that would be 11, right? So what is 11 minus 7? So that would be 4. Bring down the decimal point. Okay, so this will become actually 4. Yes. Okay, 4. And 4 minus 2 is 2. Okay, we will have to borrow again. 0 needs to borrow 1 from 8. I repeat, 0 needs to borrow 1 from 8. So this becomes 7. This becomes 10. 10 minus 8 is 2. All right. And then 7 minus 5 is 2. All right. There you go. Now, what will be the sign? Of course, here it's obviously that we're going to follow the sign of this one, of negative 805.203, because it has actually the greatest absolute value between 805.203 and 582.72. Okay, so the sign now of our answer would be negative 222. Okay, so it's going to be negative 222 and 483 thousandths. Yeah, okay. Or, easier for us to read is 200, negative 222.483. Yes, 483. Okay, so that is our answer. for example C, not Z. Sorry, C. Okay, next. Okay, so again, our final answer would be negative, um, excuse me, negative 222.483. Okay, so we're done with example C. Okay, this time we move to example D. Okay, how about example D? Now, for example D, we already have this problem. So I would say this is now um, 910.910 910 and 5 tenths or point 0.5, okay, minus negative 172 and negative, okay, we're adding plus negative, oh, sorry, let me repeat that. So we have 910 and 5 tenths minus negative 100, okay, 172 and 8 tenths. Yes. All right. Okay. So for some, they just read it as 910.5 minus negative 172.8. It's, it's up to you. All right. So, but I'm just reading it properly, of course. So what will happen here, remember the term add its opposite. Okay. That's the keyword, add its opposite. Okay. Now, so that means we're going to change the sign. Here it becomes addition, then bring down 910.5. Okay, add its opposite. What's the opposite of the negative sign here of 172.8? Of course, that's positive 172.8, right? So basically, we're not subtracting here anymore, but rather we are now adding. So let's align it together vertically. Okay, 910.5 plus, okay, 910.5 plus 172.8. Okay, and then we add. Okay, so what is 5 plus 3? Oh, sorry, 5 plus 8. My bad. I know because 5 plus 8 is 13. So I kind of mistakenly said 3. But it's 5 plus 8. Okay, 5 plus 8 is 13. That's correct. Carry 1. So 1 plus 2 is 3. Yes. Okay. 1 plus 2 is 3. Okay, bring down the decimal point here. I forgot. Okay, and then 7 plus 1 is 8. And then 9 plus 1 is 10. So our final answer would be 1083 and 3 tenths, or 1083.3. Okay, so that's it. All right. You see, it's actually easy for us to add and subtract positive and negative decimals. Okay. All right. So I hope we actually understood a lot of things. We were able to take down notes. We were able to power up our brains, just like what Digit said. Now it's your turn to actually have the practice worksheets, particularly in adding and subtracting positive and negative decimals. Okay, so we have that one part A for adding, and then for subtracting for both positive and negative decimals. And of course, we have, of course, another problem from Digit, the holographic robot. And I hope you enjoy our episode for today about adding and subtracting positive and negative decimals. Until next time, and see you, math whizzes.